Amazon Web Services is the cloud computing platform of choice in this course. And it's also the first public cloud computing platform that was created in the marketplace. It was created and launched back in 2004. Back in those days, there were two gentlemen, Chris Pinkman and Benjamin Black, that sort of came up with this idea of what Amazon infrastructure could look like and how it could be actually sold to other companies as a service. And they pitched this idea within Amazon, and out of that, AWS was born. Now, the first service that was launched by AWS is a service called the Simple Queue service, or SQS, and that was launched back in 2004. It's interesting because a lot of people assume that the very first service launched by AWS was S3 and EC2, and those services actually weren't the first services. It was this queuing service, which we will learn more about later in the course. So if you're a trivia buff, that's something that you might want to remember, is that the very first AWS service was a queuing service called SQS. AWS remains the largest cloud computing provider today. In fact, AWS is larger than the next three largest cloud computing providers combined. I mean, Amazon and their AWS is absolutely massive, and it's growing at a very fast pace. I think I read an article recently that said that AWS represents the majority of Amazon's operating profit today, which is really unbelievable. Now, Amazon.com, the e-commerce site and platform, actually runs on top of AWS, but it doesn't run on top of the same infrastructure as AWS customers are running on. So it's not like your application services running in AWS are going to be running on the same sort of shared infrastructure resources as Amazon.com. They run in a sort of completely separate, partitioned environment, but they use the same services as the services that are made available to us via AWS. So in that sense, they're sort of eating their own dog food. They're leveraging the same services that they are delivering to their customers. Why do we use AWS in this course? Well, there are a couple different reasons. I think AWS is a platform that really embodies many of the different services that we need to reinforce some of the key concepts in this course. As we look at things like cloud native application patterns, you'll find that it's very easy to implement those patterns within AWS. AWS has been around the longest, and so I think as an IT professional or software developer or data scientist, I think it's absolutely critical to have a good understanding of the largest and most popular cloud computing platform in the world. Also, if you are a college student in my course, you can receive educational credits for using AWS. So that's a big benefit. Students can learn how to use AWS and leverage free credits along the way, so you're not having to spend a lot of money while you're learning how to use the platform. I also have based many of my course lectures around the AWS certification path. So if you're looking to become like an AWS certified solution architect, you'll find that that I discuss many of the different the different sort of curriculum resources that are required in order to take that certification exam. I also discuss some of the curriculum that's part of the AWS SysOps and AWS developer certifications as well. Now, when you talk about the AWS ecosystem today, you're talking about an ecosystem which is comprised of literally dozens and dozens and dozens of different services. Every year, I update this slide in my slide deck, and the typeface gets smaller and smaller. The font keeps getting smaller because AWS literally, like every month, they're launching new services. Essentially, the mission of AWS is to deliver every single service that an organization might need. So they're literally trying to provide customers with everything that they possibly might need in order to run their business. And I think they're really succeeding at that. And you'll see that the ecosystem contains services from a broad spectrum of different categories, everything from compute and storage and networking resources to databases, machine learning, analytics, security, media tools, and developer tools. There are so many services available today that there's literally something that every organization can use. Now, in the sort of the constraints of this course, it's not possible to discuss every single service that's available or go into detail and great depth of on every single service. And frankly, I don't know every single service within the AWS ecosystem. I know many of the services, but not all of them. And in this course, we will probably cover about, maybe 40% of the services that are available within AWS. And we're focusing more on the core infrastructure building block services, things like EC2 and S3 and RDS and so on. And later on in the course, we'll look at some of the development tooling that's available. We'll spend a lot of time looking at different management tools within AWS. Some of the AWS services, when I cover them, I will sort of give you a general understanding of what that service provides, but we won't spend any time using that service in a hands-on fashion. I just want you to be aware of the fact that that service exists and that it could be used to solve some future problem. And then other services we're going to use extensively. We will do deep dives into the services in this class, and we'll spend a lot of times hands-on working with the services and trying to understand how they work. Now, it's important to understand that AWS is a global platform. I mean, truly global. AWS operates services on nearly every continent in the world today. And this map just gives you kind of an overview of the different regions of the world where AWS is operating their services. And I think the dashed lines here represent fiber optic links between those different regions of the world. AWS is constantly expanding their global footprint. They're constantly building more data centers and servicing more and more regions of the world. Now, in terms of understanding Amazon's global footprint and where they deliver services, you need to understand two different concepts. The first is AWS Regions. The AWS global infrastructure is partitioned into many different geographic regions. And each geographic region contains one or more availability zones. So think of a region as a particular geographic location somewhere in the world. In the United States, we have multiple regions. We have US East 1, which is located on the East Coast, based out of like the Virginia area. We have US East 2, which is in the Ohio area. We have then we have US West 1 and US West 2, which are located in the Pacific Northwest and in Southern California. So just in the United States, we have these, 4 different regions. And if you move then to South America and Europe and Asia Pacific and so on, you'll find that there are regions located all over the world. Now, each region has multiple availability zones. So an availability zone, think of an availability zone as being like an actual data center location within that region. The availability zones are located, far apart from one another. So you might have a region which spans, hundreds and hundreds of miles, and within that region you'll have multiple availability zones. And each availability zone might be located 50 to 100 miles away from any other availability zone within that region. So an availability zone provides you with a way to build very resilient services. You can take your application and your data and you can distribute it across multiple availability zones within a particular region. That way, if something happens to one of those availability zones, like it's hit by a tornado or fire or hurricane or some sort of human-made disaster, an airliner crashes into the data center. Well, your data and your application, your services will continue to survive because they're running in not just one data center location, they're running in multiple data centers. They're running in multiple availability zones. One thing I should note is that if you have an availability zone, there actually might be more than one physical data center in that availability zone. You might have, if you were actually drive up to an availability zone, you might actually see like 2 or 3 or 4 actual physical data center buildings that are located next to one another in a sort of a big city block or a big field or something. So it might not be actually one building in each AZ. It could be multiple buildings that are just adjacent to one another. The other thing to keep in mind is that each availability zone has its own identifier, an availability zone ID. And as a customer of AWS, I can deploy my services into a particular availability zone, and I can see the ID of that availability zone. So it'll be like US East 1A. And as a customer of AWS, you'll look at your list of availability zones that you can deploy services into, and you'll see the same ID. You'll see a US East 1A availability zone. Well, your US East 1A and my US East 1A availability zones might not actually be the same availability zone. what Amazon will do is they'll use the availability zone IDs as an abstraction. And so you never really know exactly which physical data center or availability zone your services are running in within a particular region, because your availability zone ID is going to reference a different physical data center than somebody else's availability zone ID, even if those availability zone IDs are identical. And why does AWS do that? Well, they do that because, like, if you had 1 million customers and they wanted to launch resources into US East 1, they all might decide that they want to put their services in US East 1A. And so there would be this sort of massive imbalance problem where everybody is choosing to put their stuff in the same availability zone. So AWS, they essentially sort of like randomize it so that everybody sees the same availability zone IDs, but everyone's IDs are referencing a different set of actual physical data centers.